Hi guys, in this video we're talking about limits again, but this time we're talking about connecting multiple representations of limits. So a lot of these are like test type questions, and the different representations we're going to be looking at is we're going to look a lot piecewise functions. So given a function given piecewise, we'll be given some tables, and then we'll also be given some graphs. That's kind of the main theme here. All right, so if at any point, like I feel like I might make some mistakes on this, if you think I've made a mistake, just in the comments, maybe write what the mistake is, and then if you think I've made a mistake, look in the comments, and maybe that can answer your questions. But let's get started. It says, let g be a function that is decreasing for x less than 0, and decreasing for x greater than 0. Okay. If the limit of g of x as x approaches 0 is 3, which of the following could represent the function g? All right, so I'm not real sure. I don't know what that looks like, if it's decreasing or not. But let's just mainly focus maybe on the limit being 3. So in the last lesson, we talked about how to find that limit. It's saying, okay, when the x is 0, the function is defined to be 5. But for limits, I don't care what the function is at 0. So as x approaches 0, I don't care necessarily what's happening at 0. I'm just caring that from the left and from the right, the y values are approaching 3. So let's look at this part and maybe do some. Right now, if I plug in 0, that's that 0 over 0, the indeterminate form. So let's factor the top. I'm going to say the limit as x approaches 0 of my little function, which I guess I didn't really need to write. And this negative is out in front. I got to be careful with that. That negative being out in front instead of the way I wrote it. If I wrote it up here, I would have got that wrong, because really that should have been like a negative plus. But that negative being out in front, just kind of be careful with that. All right, so this would equal the limit as x approaches 0. I'm going to keep that negative out in front. I'm going to factor an x on top, and I'd get x minus 3 over x. And it looks like that restriction cancels. So this would be equal to the limit as x approaches 0 of negative x minus 3. And at this point, now I can plug in 0 because it's not a restriction, it's not a problem. So if I plug in 0 now, I get negative 0 minus 3, which is 3. So the limit of that one is 3. So it says, which of the following could represent that? Okay, so 1 works. So this answer choice of B and C are wrong, because they say it can only be 2 or it can only be 3. So now we're down to answer choice A or D. I don't really need to check 2, really, because my answer choices kind of lead me to looking at just 3. So this is the test. It's timed. I wouldn't spend any time looking at part 2. I'm going to look at this one. But for the purpose of the notes, I am going to talk about part 2. All right, so is the limit of this function represented by a table 3? Well, when x is 0, it's defined to be 3. But remember, we're looking at what are the y values approaching around 3. And if I'm looking at the y values, they don't look like they're getting closer to 3. It looks like one's at negative 10,000, one's at positive 10,000. So the limit, it's not the same as the left and the right, and it's not approaching 3. So that's why it's not answer choice 2 or number 2. I don't know what you would call that. All right, and last one, the graph. These are my favorite because they're the easiest. I'm looking at the y values as x is approaching 0 from the left and the right, and the y values are getting closer and closer to 3. Even though the function value is defined to be 1 when x is 0, I don't care about that. I'm talking about limits. So the answer would be D. The limits of both of those are 3. Let's do another one. We'll do one more together, and then I want you to start pausing, trying the problem on your own, and then checking your answer. See if we get the same thing. All right, well, we'll talk about this one together. If h is a piecewise linear function such that the limit of h of x as x approaches 3 does not exist. So it means the left-handed limit, the right-handed limit aren't matching. That's one way. Which of the following could represent g? So I'm going to plug in 3 here. If I plug in 3, direct substitution, 12 minus 3 is 9. So the limit as x approaches 3 from the left of h of x is equal to, I forgot what I said, 9. And then I could say the limit as x approaches 3 from the right of h of x. Now plug in 3 there. 3 times 4 is 12. 12 minus 3, that's 9. Now, if this is multiple choice, I don't need to write out all this notation. This is just there so we get used to seeing it, used to writing it. But there, it looks like the left-handed limit, the right-handed limit are the same number. So the limit is 9. That means it's not exist. Okay, I think I confused myself. So this is not an answer choice because we're wanting to know which ones have limits that don't exist. And that one looks like it does exist. So that's not an answer choice. It's not A. Okay, at least not A. All right, tabular. Let's look at this method. So as x is approaching 3, well, right there is defined to be 0. I don't care about that. Now let's look at the left side and the right side. It's kind of hard to tell. Does it look like the limits are approaching the same number? Or what number are they approaching? I don't know. Okay, so this one looks like it's 9/3. This one is 8/3. This one is 7/3. So the next one would be 6/3, right? If that pattern was continuing, so which is 2. So from the left, the limit is 2. So the limit as x approaches 3 from the left of h of x in this representation would be 2. And from the right, it looks like it's going down by 1 each time. On the left side, it was going down by 1/3 each time. That's how I saw that pattern. So the other pattern, it's linear, needs to be going down the same amount, so it'd be 1. So the limit as x approaches 3 from the right side of h of x is 0. So since these numbers are not equal, the limit does not exist. So that means we can cross out answer choice C. And then if I look at 3 really quickly, or sorry, not answer choice 3, the limit from the left looks like it's 2. The limit from the right is 0. They do not match, so the limit does not exist. So the answer would be D. All right, so from these, I want y'all to pause the video, try these on your own, and then see if we get the same thing. And if we don't get the same thing and you think you're right and I'm wrong, write it in the comments and have a discussion with people. Let's see. All right, if f is a piecewise function with 2 linear pieces such that the limit as x approaches 5 does not exist of f of x, which of the following could be representative of f? All right, so the limit has to not exist, so I'm going to do this one with less notation. I'm going to plug in 5 there. So 10 minus 1 is 9. Plug in 5 there. 14 minus 5 is also 9. So the limit of this one is 9, which means it couldn't represent because the limit as x approaches 5 of f of x has to not exist. That's what we're looking for. But that one does exist. It's 9, so it's not one of those. All right. Tabular, looking at the table. Looks like the pattern's going down by 2 each time. So down by 2, down by 2, down by 2. So from the left, I don't care what it is at 5. But the limit as x approaches 5 from the left of f of x, that looks like it's going to be 4. This one's going down by 5, down by 5. The next one going down by 5, the limit as x approaches 5 from the right, that would equal, I already forgot, 1. So that one, the limit does not exist because the left-handed limit, the right-handed limit don't match. So this one could represent f. And then the graphical way, the fastest one, the limits don't, from the left and the right, they don't approach the same number. So that one does not exist also. So it could represent f. All right, next one. All right, is this the tricky one? There's a tricky one here in a second. Okay, let f be a piecewise function. It says 2 linear pieces. Well, the limit as x approaches 5 is 1/4. Which of the following could represent f? All right, so I don't care what it is at 5. So who really cares about that? I need to see, is the limit 1/4? Not just does it exist, is it 1/4? So I'm getting pretty good. I realize I need to factor that. I should maybe go ahead and write limit. X approaches. Now, for the multiple choice, you don't care about notation on the actual test, but right now we're just practicing, making sure we're writing all this stuff correctly. I would say x minus 5. I need to factor this trinomial on the bottom. I'm guessing one was going to be x minus 5 and x minus 1. That cancels, so the limit... Okay, I did the wrong thing. I need to be careful, and I need to write the limit as x approaches 5 here. Okay, I'm kind of bad at that, so be on the lookout for this. I get lazy sometimes. So the limit would equal, say we're practicing notation, and I'm doing it all wrong. X minus 1. So now we can plug in 5 and we get 1/4. So that one could be it. All right. Next one. All right, so this one's a little tricky. Now, is it linear? It's kind of hard to tell that these are linear or not. We're just going to assume that they're linear. But what I want to see is, are these numbers approaching 1/4? And remember, 1/4 is about 0.25. It looks like it is. I don't know like a lot of words to say or how to like really prove it, but it just feels like it. If I'm looking at it, 4.9999 is really close to 5, and 0.249 is really close to 5, or 0.25. It looks like it's getting it from underneath, from the smaller numbers. The limit as x approaches 5 from the right of f of x, well, it feels like it is. I can't confirm that it's linear, but it looks like it's going to be 0.25 also. So I would say this is it. All right, last one. Limit does not exist on this one, so we're just going to cross it out. We want to find the limit to be 1/4. All right, 2 more examples. Hopefully you're pausing these and then moving on. And then see if you got them right. All right, let g be a piecewise function with 2 linear pieces, where the limit of g of x as x approaches 3 is 6. Which of the following could represent the function g? All right, so around, when x is 3, I'm going to factor this. So the limit as x approaches 3 of g of x is equal to the limit as x approaches 3 of the factored version, x minus 3, x plus 2 over x minus 3. That cancels, so this would be equal to the limit as x approaches 3 of just whatever x plus 2 is. I can plug in 3, I get 5, right? I'm going to mess up adding numbers, I can feel it. So that's not it, right? It's close, it's not 6 though. Even though this said 6, I guess that's where they're kind of trying to throw you off. All right, looks like this one, okay, it looks like the limit from the left is going to be 6, the limit from the right is going to be 5, so that's not 6. And this is the tricky one because the graph, that's linear, this is nonlinear. And if it says they're with 2 linear pieces, so I could see where you would say, yeah, that could work because the limit looks like it is 6, because the limit's definitely 6. But does it satisfy the 2 linear pieces? Technically, no, but I could see. But the limit as x approaches 3 of that function is definitely 6. So that one's a little tricky. All right, last one. Hopefully you're feeling more confident with these than you did at first. All right, if h is a piecewise function with 2 linear pieces, I mean, we'll see if we can confirm they're linear or not, but the limit as x approaches 4 of h of x does not exist, which could be h. Well, this looks like from the left, when x is less than 4. So if I plug in 4, half of 4 is 2, so that'd be 5. Plug in 4 on the bottom one. What's that? 13 minus 8. That's also 5. So the limit as x approaches 4 of h of x, and this one looks like it's 5. It's not non-existing. So that's not it. It looks like these going down by, it's all about 4, right? Don't care what the actual value is at 4. What's happening to the y values around 4? That's going, looks like up by 3, plus 3, plus 3. So at 4, it looks like these y values are getting closer. So what, maybe 5? So limit as x approaches 4 from the left of h of x is equal to 5. Okay, 18 thirds, 17 thirds, 16 thirds. These are going down by 1, by 1, by 1. So the next one would be what, 15 thirds? If that pattern continues. So it looks like the limit as x approaches 4 from the right of h of x is also 5. Those match. So the limit is 5. It doesn't not exist. So that couldn't represent it. Hey, here we go. From the left, from the right, they don't match. That's the one. The limit does not exist. All right, as always, if you have any questions, if you missed class and you're watching this video, or you just weren't quite sure what we talked about in class, you weren't focused, or just wasn't clicking and you watch it now, hopefully this makes more sense. And if not, ask questions next time I see you in class.